Kiagu, and I am representing group 22. In this part, I will explain the values selected for vibration analysis and how they were modeled in Ansys for validation. The system is simplified into a 2 degree of freedom model, where the two central monorail coaches are represented as masses and the couplers are represented as spring stiffness elements. For design 1, different stiffness values were selected from the table 4 to represent different coupler matrices, with K1 value of 400 kN, K2 300 kN, and K3 600 kN. For design 2, the same material was assumed for all the couplers with a value of 450 kN. To perform the validation in Ansys, both masses were modeled as solid steel blocks with a density value of 7850 kg per meter cube. The required volumes were calculated from the mass density relationship and simplified as cubic geometries. These resulted in cube dimension of 569.508 mm for mass 1 and 562.885 mm for mass 2.
First of all, we have to click model and have to create a new design model in the geometry. Since I've done the analysis of both design 1 and design 2, I'll just go through with what I did. So after clicking the new design model, we have to click the sketching and create a rectangle to represent the mass 1 and specify the dimension for it. So for the L1, which is 569.51, same with the L2, and for the H3 is 284.75. So after specifying the dimension for it, then we have to extrude it. Same goes for the second cube. We have to specify its parameters, which is L5 is 562.88 and L6 is 562.88. The V9 is 281.44 mm. After specifying its parameters, then we have to extrude it. The distance between mass 1 and mass 2 we assume to be 1000 mm. After creating the geometry, we have to edit the model. The model software will be opened, and before drawing anything in it, make sure the material is in a structural steel, and then we can start to add the connections for it. So first spring we have made it to be ground to solid, and the value for it is 400 kN, and we have specified the reference x coordinate to be -1000 mm. So for the second spring we have made it to be solid to solid, and the value is to be 300 kN. So we have made it to be body to body for the mass 1 and mass 2. So after setting it up, it will start to appear the spring 2. Then for the third spring, we have made it to be ground to solid, and the value is to be 600 kN. So the spring length is 852.36 and the reference x coordinate is 2100 mm. Before setting it up, make sure the units all are correct. So after generating all of the 3 springs, you can start to generate the mesh. So once the mesh is complete, the model A5 will have a tick on it. Then after creating the mesh, we can specify the maximum mode to be 2, and then we can add the remote displacement for the mass 1 and mass 2. So the remote displacement for the mass 1, the x component will be free, other directions all will be 0. Same goes for the remote displacement 2. The x component will be free and other directions all will be 0. In the remote displacement, we have to click solve in the model A5. So once the model A5 is solved, the total deformation will be appeared on the solution A6. The total of 2 deformation will be appeared. The natural frequency can be found over there. The natural frequency is 2.9241 and the second natural frequency is 4.4679. So the first deformation, the maximum deformation is 0.68364 and the minimum deformation is 0.47982. These values can be used to calculate the modes for the first deformation. So the first mode shape can be determined by dividing the minimum value and the maximum value. So the answer will be 0.7012. We have gotten a 0.69474 maximum value and 0.47147 of minimum value. So this can be used to calculate the mode shape 2, which is 1.475682. The value can be determined by just dividing the maximum value and the minimum value. So the answer is same as the ones we have calculated in the theoretical value. So the answer in the theoretical value we get negative because the masses are moving in an opposite direction. Because of that, the mode shape in the theoretical value is negative. So the value for the mode shape in the Ansys also, we have to put negative in front of it. For the design 2, the steps all are same as the ones we have done in the design 1. The dimensions for the geometry will all of them will be same as the ones we have done in design 1. We can start to edit the model. So for the model, make sure the material is in structural steel and all of the spring connection will have the same value of 450 kN. So for the first, for the design 2's natural frequency, we get a value of 2.828 and second natural frequency is 4.8998. So the maximum value for the first mode shape is 0.59743 and 0.58704. So the first mode shape can be determined by just dividing the minimum value of it, minimum value and the maximum value. So we'll get a value of 0.9826 for the first mode shape. For the second mode shape, we will have a maximum value of 0.608 and 0.57683. To calculate the second mode shape, we just have to divide the maximum value and the minimum value. We will have a 1.054 of second mode shape. These values all are same as the ones we have calculated for the theoretical calculation.